This week we are supposed to have homework 8. I decided it's going to be due, or supposed to be due at midnight on Sunday, which is basically immediately before the exam. So I decided to push that back a week. So you won't have a homework this week, but the homework that you would have been doing this week, you will be doing the following week. So I guess the drawback is that there's a bit of a delay between the lecture and when you actually do the homework, but I'm sure nobody's going to be too upset about that. So it'll be due Sunday the 19th. I will post something on Piazza just to make it official, I guess. But that'll be the case. In terms of the material then that we cover on the exam, I still want you to be familiar with what the subject matter of this homework would be, which is internal convection and internal energy balance. But let's say I won't ask you to maybe go into the level of detail on that I would for the other topics. So still be familiar with it, but I'll keep in mind the fact that you haven't had a chance to do the homework yet when I'm writing the exam. Okay, so homework 8 will be posted then, let's say, later. Not right now, but maybe in the week, and then you can decide when you want to start that. That brings us to point 2, which is exam 2. This kind of snuck up on me, but it is next Monday. So next Monday in class, starting same deal as before, 3:25 will start, so show up a little early, be ready to go, and then you'll have a full hour to do the exam. I will, I'll cover in the exam stuff from lectures 9 through 16. So remember all the way back to transient conduction. Transient conduction problems will be covered on this exam. I would strongly recommend that you go back and refresh yourself on that stuff. Those tend to make good exam problems. And then we talked also about convection and internal energy balance. So be familiar with external convection flow over a flat plate, boundary layers, how you do the conceptual model of heat transfer when you know the boundary layer thickness, how you apply correlations, that type of thing. So pretty much everything from, I think, the stuff we'll kind of finish talking about today back to transient conduction will be on the exam. It's not really cumulative, but if you didn't understand stuff on exam 1, you probably want to make sure you do just because it's foundational, right? Yeah, so the question was, what will you be given? I will again post the PDF supplement that you'll be given so you have enough time to look at that. Generally speaking, what you would be given is let's say I ask you to derive a correlation or derive a Nusselt number from a correlation. I would give you something like this. I'd say, here's the correlation you want to use, this table, or this chart, and you could go pull the value, but you need to know how to use it. Or I'd give you maybe a table of correlations and you have to choose the right one on a convection type problem. But I'll try to post that, say, in the next couple of days so that you can see what type of thing you can expect. Reminder on the notes, so it's open note to the point that you can include now 4 sheets front and back, so 8 sides. What I would recommend is maybe just take your first 2 from the first exam. You can bring that with. And then add 2 new sheets, or if you really are ambitious and want to do 4 new, I don't care, I'm not going to check anything. So, and then, by the way, keep those, don't turn them in with your exam, they are your resource. Reminder then, okay, so after exam next Monday, there's no discussion on Tuesday, so that'll be canceled. Questions?
Is there going to be a practice exam posted like last time?
Yeah, I'll come up with some practice exam based on what's written, so. I'll post that to the files folder that I'll create for exam 2, and then a Piazza post will give you instructions on that. Anything else? Okay. Let's go back here and just remind ourselves what we talked about last time, and then I want to go back and finish up the last part here, which is the specified surface temperature. We didn't get to that. But remember last time we were talking about internal convection correlations and internal flow energy balance. So we went through that whole classification thing where we said, here's all the things you need to think about, and here's how you'd figure out which features you include in a correlation. That kind of messy looking chart that we filled out. And then we went through and looked at specific examples for correlations for friction factor and Nusselt number, looking at how the average and the local are related to each other. We did at the last part of the last lecture go through a solution for specified heat flux and internal flow. So if you remember, model for, let's say, we're trying to develop a model for the mean fluid temperature for internal flow. And then we went through the derivation. We applied the control volume analysis to the fluid itself, what's in and out and like heat that's being added or lost. For this specified heat flux case, so we know this heat flux, and that gives us this linear relationship. So we just say, okay, the inlet temperature, we know that the mean temperature is increasing linearly according to the amount of heat flux that's being added, multiplied by the position x. Okay, so that's kind of as far as we got. I didn't finish the last part, like I said, so let's go back now and go through this idea of specified surface temperature, and you'll kind of see how those are different.